Hi everyone, welcome to video 1 for quadratic functions and their graphs. So for this video, we're going to look at part 1 of the worksheet that I have linked on the Canvas page with your videos. So we're basically going to be looking at how we can transform, or in other words, move a quadratic function on a coordinate plane. So if you notice, if we're looking at groups A, B, C, and D, the first function, f of x, is the same throughout. So this is what we would call the parent function or the toolkit function. It's going to vary depending on what resource you are accessing. So essentially, this is just the stripped down, most basic form of what a parabola will look like. Notice that once you go to either the function for g of x or h of x, this is when we start to include numbers, whether they are positive or negative integers, maybe fractions. And for this video, we're going to be investigating group A and group C. So what I want you to do is make sure that you have your graphing calculator handy, and we're going to just look at this visually and see what happens when I multiply my quadratic function by a 2, or what happens if I multiply it by a -1/2. So from there, we'll be able to answer these questions below. So let's go ahead and move over to our calculator. And again, we're just going to look at what the graphs look like. So at this point, we're not going to graph them by hand. We're just going to kind of start off with just looking at the visual. So if we go into y equals, I'm going to go ahead and put my parent function in first. So my variable key is next to my alpha key. And then my squared key is right above the log key. So here's my x squared. And then I'm going to arrow down to the second line, and I'm going to create that 2 times x squared. So I can do 2. You can choose to put the multiplication in there if you would like, but please note that if you just type 2 followed by the variable, the calculator assumes that there's a multiplication happening between them. And then we're going to do squared again. From here, I'm going to go ahead and graph. So again, my parent function, or my standard parabola, is going to be in blue. And then the red one that's going to come through is my transformed one. This is what happens when I multiply my x squared by 2. And notice that it looks like it's pulled in closer to the y-axis. It's definitely closer. It's almost as if I had taken the edges of, or the ends of the blue parabola and pulled them upward. So multiplying by 2 actually means I'm going to make that function grow faster. You figure if it grows faster, it's going to shoot up quicker. So this is why it appears to be closer to the y-axis. It's actually growing twice as fast because I'm using a 2 in this case. So this leads us to the next function on our worksheet. So let's go back there and make sure that we have that idea down. So our next function is going to be h of x is equal to -2x squared. And we want to ask ourselves, well, what happens now if I put a negative in front of it? So we'll go back to our calculator. And again, we're going to go into y equals. And I'm going to opt to work with the third line. And I'm just going to recreate what I already have from above. So first, I want to hit the negative key, which is going to be to the left of the enter key. Remember, the negative key is different from the subtraction key on your keypad. So we're going to do 2x, and then we will square that. And again, we'll have all 3 on the screen now, so we can kind of look and see what the difference is. So again, our first 2 functions remain the same. And then the next one that should be coming up will be outlined in black. Here it comes. So something to make note of here, it looks identical to the one that I have in red. The only difference is that it's flipped, or it is reflected over the x-axis. Essentially what this means, when I put a negative out in front, all the positive y values in my coordinates now become negative. All right, so we've gone ahead and we've noted this. So what I would encourage you to do is let's go back to our worksheet and let's talk about these things. And I would encourage you to take some notes as we discuss this. So for number one, describe how the graph of g of x equaling a times x squared, in this case 2 times x squared, compares to the graph of f of x equaling x squared if a, in other words, this leading coefficient, is greater than 1. Well, we know what happens here. When I use something that is bigger than 1, my parabola is going to basically stretch or grow faster or pull in closer to our y-axis. In other words, it's going to get tighter looking. So for number 2, we're not able to do that one yet. We're going to investigate that one with group C. But number 3, describe how the graph of h of x equaling negative ax squared compares to the graph of g of x equaling just a of x squared. So if we go ahead and we look at g of x and h of x in group A, what happens when I go ahead and include that negative or make that 2 negative? Basically, we see that it flips over the x-axis. It's almost as if you put a mirror right on top of the x-axis and you see everything reflected downward now. So let's go ahead and look at part C. So instead of a positive 2, we're going to work with a positive 1/2 for our function g of x. So let's hop back over to our calculator. Go into our y equals screen. I am going to go ahead and clear out my third line because I don't need that right now. And for our second line, I'm just going to go ahead and overwrite this. So in parentheses, I'm going to put 1 divided by 2 to indicate that I'm working with a 1/2. Or if you wanted to use the decimal equivalent of 0.5, you could do that as well. And then we will put our x in. And it looks like we're all set. So now we have 1/2 x squared. Let's go ahead and compare this one in our line 2 to our parent or toolkit function from line 1. So again, here's our parent function. And here is what happens when I multiply our quadratic by a 1/2 instead. Notice that instead of being inside when it was closer to the y-axis, it's now actually further out. So essentially what we are doing here is we are compressing it. It's almost as if someone came along and took the ends of the parabola in blue and applied pressure to them. Things are going to start to buckle and kind of slowly move outward or bloom outward. So the reason for this is because when we multiply 1/2 by 1/2, we're saying, hey, grow at half the rate that you usually do. So if I'm growing at a slower rate, it's going to take me longer to reach these destinations. So the last part, as before, what happens if I go ahead and make that positive 1/2 a negative instead? Let's go into our y equals screen. Let's arrow down to line 3. And let's go ahead and type in a negative 1/2. Close that out and multiply that by an x squared. So when we hit graph again, we'll go ahead and we will see all 3. Again, here's our original 2. And take a look at that. So our third parabola looks very similar to the one that we have in red. The only difference is that it is reflected across the x-axis. The negative basically just makes everything flip. So in this situation, if you have a positive lead coefficient, everything is pointing upward. It almost looks like a smiley face. But then when you make it negative, it's a frowny face. So this takes us back to our worksheet. Specifically to question number 2, where it is saying describe how the graph g of x equaling ax squared compares to the graph of f of x equaling x squared if that lead coefficient is between 0 and 1. but note that a is positive but less than 1. So this is referring to the g of x function. So what we can say here is that when we multiply our quadratic function by a fraction value, a positive fraction value in this case, we're going to see the parabola compress, or it's going to open up slower, or it's going to be wider, using any of those descriptors. And then again, we could go back to question 3 on this worksheet and note, and by the way, if I make that fraction negative, the same outcome happens, just like when we had made the positive 2 negative. Everything flips over the x-axis, or it reflects over the x-axis. All right, we are ready to go to video 2.